Good morning, students. In this video we are going to talk about wave theory of light. So mainly in this 10 minutes video we are going to talk about what is wavefront, then we will talk about Huygens geometrical construction. Okay, so these three topics we are going to cover. The first thing, we will understand what is the wavefront. For that, let me go for the small simulation to understand that. So we have here a small PhD simulation I am using. So you can see source of light here, and when I switch on the source of light, so you can see that the disturbance is created there. That defined as the continuous locus of such particles of the medium which are vibrating in the same phase. So all these locus of points which are in that medium are vibrating in the same medium. Let me take that. These all are wavefronts. This is the one more wavefront. This is one more wavefront. Thus all are vibrating in that medium with the same phase, and their speed, which is moving outward, they are moving with the same speed. So speed with which the wavefront moves outward from the source is called as phase speed. We call as phase speed, right? So these are, that is Huygens principle. Let us take the Huygens principle. So let us understand the Huygens principle now. So what the Huygens said, light is having the wave nature, and to explain that wave nature, he made some assumptions. So we call those assumptions. What he said that each point on a wavefront acts as a fresh source of new disturbance. So those new disturbances are called secondary waves or wavelets. Okay, let us understand this. So let us say we have a source here. This is producing the disturbance. This source is producing some disturbance in the medium. So disturbance are traveling like this. These are the wavefronts, spherical wavefronts, which are coming out of that point. This coming out with the speed of c. So these are called as wavefronts. So this is one wavefront, and the second wavefront is third wavefront, right? So they are in the same phase now. That's the meaning of it. So then what it says here is, let us take at some instant of time, I'm taking the wavefront which is at this. So this is the wavefront which I am considering. So I will highlight with the different color. So this is the wavefront which I am considering now. At some instant of time, so I consider this wavefront. So now, and this I will take at different points. So I will take one point here, another point here. So I go on taking different points. Now each point will act as now source of secondary waves. So means each point on this wavefront act as a fresh source of new disturbance. So meaning is, so at each point the new disturbances started creating it. So at this point one more, at this point one more will create, at this point one more will create, at this point one more will create, this point one more will create. So I'll take one more here also. I'll take one more here also. This is the meaning of that principle. So each point acts as a source of new disturbance. Let us take the second statement of this principle. What he says that the secondary wave are the secondary wavelets spread out in all direction with the speed of light, or with the speed of light in that given medium, with the speed of light in the given medium. Okay, that's one thing. Next, you understood this one, so it means it is traveling with the speed of light outwards. Each one of it's going outward with the speed of light. So that's the meaning of it. So means the distance which it covers, this much distance here. So we call that as C into T, or if it is traveling in a different medium, we'll call it as V into T. Now, the third statement is very, very important. The new wavefront at any later time, at any later time is given by the forward envelope. So of the secondary wavelets, at that time. Meaning of that, these all red colors are the secondary wavelets. And what is the meaning of forward envelope here is tangential surface in the forward direction. That's the meaning of the forward envelope. So this forward envelope, so I will take each point here and I will draw a tangents to them, tangential surface I will draw it. So I'm going on drawing the tangential surface on them. So I will get one forward envelope. So this forward envelope is the new wavefront, or you can call that as a secondary wavefront. Which is moving in a forward direction. So this is the meaning of the Huygens principle. And what I told you just now, it's also a geometrical construction. So with the principle I explained geometrical construction. We will take one more example with respect to plane wave. So just now I was talking about the spherical wavefronts. Now I will talk about the plane wavefronts. The Huygens is saying that each point on this plane wavefront, each point on it, so I will name those points A, B, C, D, E, F, G. So these are the points which are on the wavefront AB. And what it exactly says is, so this A, B, C, D, E, F, G acting as a fresh source of new disturbance. That's all the first statement says. So, and the second statement says that those the new disturbances, we call it as a wavelets, those wavelets spread out in all directions with the speed of light in that medium. And the third statement says that those wavelets we will draw first, then I'll come back to the third statement. This is the wavelet which comes out from the source A. This is the Second called wavelets. Now, on this wavelets, these wavelets are moving outwards with the speed of c. They are moving outward with the speed of c. The third what it says, so it's saying that take the point on the surface of this wavelets and draw a forward envelope. So after a time t, meaning I'll take the points here, a dash, b dash, c dash, d dash, e dash, f dash, g dash. So now I will join all those points. So if I join all those points, now I'll get a new wavefront. The new wavefront is C D, forward envelope. And you may be having a doubt that so the backward envelope also means if I join all these points here, it gives the backward envelope also. Alright. So you may be having doubt why I'm not considering the backward envelope. So I have an answer for that. So the answer is action. So there cannot be backward flow of energy during the propagation of the wave. No backward wavefront is possible. Video, we will see that loss of reflection on the basis of Huygens theory and loss of refraction on the basis of Huygens theory.